Hello everyone, my friends and everyone watching me, wherever you're watching me from. I just want to thank you guys for your support, for your likes, for your comments, and for your encouraging statements. And today we're going to go on a very interesting video, which is useful to us in biochemistry and also in chemistry. And that topic is talking about one of the separation technique called chromatography. So we'll be talking about briefly on the concept of chromatography. So in this concept, so in this area, we just talk briefly some major points on what we have here on the board, which is chromatography. Now, chromatography is, as I earlier said, is a separating technique. It's one of the separating techniques. And this techniques is very important to us in the sense that chromatography helps in the separation of the component of mixtures between two phases. And I said here that it's a method by which a mixture is separated by what? By distributing its components between two phases. And basically, we have two phases. But the two phases are one, we have the mobile phase and we have the stationary phase. And that the stationary phase remain fixed in place. And that the mobile phase carries the component of the mixture through the medium that is being used. Now, the principle behind chromatography is that it allows the molecules that are present in the mixture to what? To distribute themselves between the stationary phase and the mobile phase. And that chromatography as a very important area in separating techniques enables us to what? Like it enables us in the separation, the identification, and also the purification of the component of mixtures that is useful for qualitative and whatnot and quantitative analysis. Now, we have said that the components that are strongly retained, the components that are strongly retained in the stationary phase, they move slowly. The components, it's a simple idea that the components that are strongly what now? That are strongly retained or absorbed in the stationary phase, they move slowly in the flow of the mobile what? The flow of the mobile phase. While the components that are weakly retained, they move rapidly. For example, if I'm having between oil and water, because oil is strongly absorbed to the surface, they tend to move slowly compared to water that is weakly retained and will move what rapidly. So these two concepts will help you in we help you when we talk about the each of the types of chromatography and while we're explaining it. That the first point here, that the components that are strongly absorbed or retained, they tend to move slowly, while the components of the mixture that are weakly retained, they tend to move what? Rapidly or very fast. Now, and that this chromatographic process occurs due to the differences in the what now? In the distribution was constant of the individual sample components. Take note that the chromatographic process occurs due to what now? The differences in what now? In the distribution was constant. That's when you begin to compare the concentration of the stationary phase with the what now? With the mobile phase. And we have said that a partition coefficient or a distribution coefficient is the ratio of the concentration of a compound in a mixture of two what now? Of two immiscible solvent at equilibrium. Look at the statement here. Two immiscible. But it cannot be mixed in a layman term, cannot be mixed. two immiscible solvents at equilibrium, meaning the ratio of the concentration of two immiscible liquids, and that Kd is equal to the concentration of the what now of the stationary phase and the concentration of the what now of the mobile phase, which is this is the formula of the what, that's Kd, that is the concentration, at the constant there. So under chromatography is classified based on theory rules, and that one is based on the mobile phase, two according to the packaging of the stationary phase, and lastly based on the force of separation. Now, and that, as you can see, these are the various types of chromatography, but that these various types of chromatography are classified based on theory rules, which I've told you earlier, and that under based on the mobile phase, we have the liquid chromatography, we have the gas chromatography, and that in the case of the liquid chromatography, the mobile phase is a liquid, from where the name comes from. While in the case of gas chromatography, the mobile phase is gas. Please take note. And that according to the packaging of the stationary phase, we have the thin layer chromatography, we have the paper chromatography, we have the column chromatography. In the case of the thin layer chromatography, the stationary phase is a thin layer that is being supported on a glass, plastic, or aluminum plates. While that of the paper chromatography, the stationary phase is a thin film of liquid supported on an inert support. Inert. That's unreactive. Inert support. While in the case of the column chromatography, the stationary phase is what now? Is found or is packaged into a glass chromatography. Into a column chromatography. And material based on the force of separation, we have adsorption chromatography, we have the partition chromatography, we have the ion exchange chromatography, we have the gel filtration chromatography, and lastly the affinity chromatography. And we have said that these 5 here fall under what we call, meaning they are being separated based on the force of what now? Separation. So in our subsequent video or series under this area, we'll be picking each of these chromatography, like each of these types of chromatography. Then we'll be talking about their uses, their importance, their working principles, and some major points that are worthy of notes for you guys. So for now, thank you. God bless you. Please do well to subscribe to my YouTube channel and share this video. God bless you.